reason why you go a little up so that, just for the sake of it, right? Because the highest number is 28 and the lowest number is 1. Oh, that makes sense.
Yeah, you do that because I think in stats they call that's your range, right? So
I
your
believe so, yeah.
so your range. I mean, sometimes I get confused in what they mean. I know range is usually, but I know in statistics sometimes they. I'm just going to say range for rainfall is going to be one bracket to 28, right? And we've already accounted for that. We're going to say that the domain, please excuse the digital writing, domain is going to be 1 to 12. Pretty straightforward. All bracketed. 115, that's right there. And then we got 2 and 21, 3 and 28. Pretty straight line. Um, 4 and 24. And I'm going to, pause and get the rest of the dots. So again, I want you to notice how they're scattered because in chemistry we'll take when we do the best fit line, the computer gets a best fit line that goes through them as straight as it can. And just to kind of clarify, like if this looks more curvy, because notice how it's doing this. And I could show you how to generate curves too, like best curves, okay? And that's the knowledge of,
Okay.
yeah. So now 8 and 1. Now it says for her a line graph. So I don't want to seem like I'm perplexed because if I was doing it in really real life, like a real scientist, a legitimate universal scientist, no matter what planet I'm on, then I see a curve, right? Naturally, I'm going to probably shoot for that, but we'll see in a minute what we need to do because it does say line graph. So if you will, while I do this, will you look to see through her rubric if she wants a curve for this or not? Notice I'm like going real slow because I don't want to mess it up again. 11, 5, and 12 and 10. Now this is really interesting because when I tutored you in algebra, what does that look? That looks like a polynomial, doesn't it?
Yes, it does.
There's only one problem with this. Not really, but we don't know. We could approximate a cubic one, right?
Right.
We sure could. And let's think about what a cubic function has, right? Something like that. And so right now, this is like a little uncommon. We're thinking outside the box because typically we do best fit lines, but your teacher, we can't do best fit lines here. It would be really terrible. It'd be a bad best fit line because are we going up or are we going down, right? This would be really bad. There's a lot of error because every bar these gives you a sum of errors. Notice how like this is a lot of error bars. So a best fit line here would be
Right.
very uncouth. I wouldn't recommend doing a best fit line. I would recommend doing a cubic one. What we could do is we could select maybe 4 points. 1, 2, 3, 4, right? Because we have like, and we can have like 3 of these or 4 of them. And this is a technique I haven't shown you yet. And what that is you'll plug an X in, right? We don't have a 0 value for D, but you'll plug an X in. So I have 1 and 15. So then or we'll stick to the rubric. V of, I'm using X, but I mean T. Geez, I'm not redoing that. Give me a second here. I'm trying to demonstrate. Oh my gosh. Why did your teacher start you out on a cubic the first one on the third day? That's ridiculous. Hold on, give me a second. Very uncouth. I like her
I
style. I like that but she hasn't really said anything about doing a cubic graphic yet. She gave you that. Give me a second. So again, we're going to attempt to find a cubic function. We're going to see if we could get an exact solution to this. And what we're measuring out are the coefficients A, B, C, D, right? So once we put this in our matrix, we'll be able to do reduced row echelon form on this, okay? Which is usually
Okay.
well beyond a high school chemistry course. Even in college, we didn't start out with this one. So, but I'm going to do it anyway. So, and I'm going to do the best I can to.
It's fine. At least I'm learning college chemistry now.
Yeah, I know. We don't want to. Thank you. We don't want to overdo it, but she didn't really give us anything but something cute. That's cute. I'm the best cubic. I could do a quartic, might get a better one, but we're just going to aim small, miss small here. And I can get us something. We're going to try to put it in Excel to get a more accurate one as well. But I also have some formula. I only have the formulas for the linear from my IB school I worked at, but we'll see what we can do. Plus, again, if you have A plus, if you know what you're doing, like I did earlier, then you use technology, right? Because if you did this by hand, you would never get it done. And we're going to do it with Excel as well. It's the only way to do it is to use technology. But you got to know what's going on conceptually. So I have to hint that you should know that's cubic behavior. With quartic, we could, but we don't have those points. So we're going to stick with cubic. It's probably going to be more accurate. Through it in AI, we got these numbers once it crunched all of this. So just to kind of keep that consistent, I'm going to put that on this page somewhere up in the corner so we're not losing focus there. So let me get everything on first. So in Mathematica, I also provided all of this, right, so that you could see this can be done exactly like I have it written. The outside brackets are the whole matrix. The inside brackets are your rows. You do include the column vectors. You augment it, right? So we know that the augmenting matrix, right, if you're doing this by hand, which you should not be, because you're going to get decimals, as you can see. So if you did that by hand, you'd never get there. You'd be well beyond Elon Musk and Einstein's capabilities. I don't know if Elon's, I'm just saying. So the way your matrix is usually set up by hand, just so you have it, is you augment 1, 1, 1, augment bar, 15. Remember, any reduced row that we do on something, remember, you will be doing the inverse matrix, but you're not really doing that. You're just doing reduced row echelon and getting your pivot columns and so on, right? So I'm just going to do it out by hand to show, that we still understand our math conceptually. We're not cheating. You're not going to do this by hand. If you do, you will fail. Sorry to sound like a villain here. 12, 1, 10. All right, and then we do, this is by hand. You would do RAF, but what we do in Mathematica is row reduce of that matrix. Same thing. Matrix form gave me these. Numerical gives me these. And if you look at your, and I find this to be one of the most conducive ways to do it. But AI does it much quicker, right? If you don't know what you're doing, though, you can't use AI. That's the kicker. So we're not going to get into I don't have the energy to argue with teachers on that. That's just a lack of them. That's insecurity and their self-efficacy. However you pronounce that. But then there we go. You get your notice how you get your A, B, C, D coefficients, right? Once you get your A, B, C, D coefficients, then you write them in, and you'll get this right here. I'm not going to rewrite it. So notice that A gave you the 0.21818 t cubed. So in other words, you would be putting each one, right? Because what that tells you that from our matrix form, that tells you that A, B, C, D solution vector is now equal to, notice that when you transpose the solution vector, or sorry, the ABCD into that, that tells you your solutions. So I'm not going to get into the video on algebra, how we do this. This is chemistry, we should know by now. But I'm just going to put your ABCD solution vectors, right? Skipping the whole. Let me go ahead and like put what that is. I'm trying to make it to where it's understandable to the viewer. Um, again, I'm not going to go into why that is when we take, because what it is this. If you've got that and your variable vector, which is the ABCD, I'm just going to put X, right? And that was equal to the 15,
Right.
28, 1, and 10. So that would have been your B vector from what we did in algebra. Sorry if people are getting lost on this, but this is how you do it. So now this is going to be equal to that. Well, if I take the inverse matrix, remember when we did that video, I have a video on that in College Algebra and Algebra 2, where you do that, you nullify that. And so now your solution vector, which is the ABCD, and not to be confused with B and B here, the ABCD, right? So your, which is X, right? That's going to be what I'm using for X here, big old X, big X, is going to be that times that. Now, if you're doing reduced row echelon form, right? Then when we went through that video, we realized that every operation we did at Gauss-Jordan elimination, we had to apply to both the column vector as well, because every single thing that we did in reduced row echelon form, every single conserved operation was in fact the entire inverse matrix. So that's why the ABCD is equal to the A inverse times B by hand. So if you're doing the augmentation by reduced row echelon form, then every operation, of course, is going to get multiplied to everything inside A and everything times your column vector. Again, that's every operation in row reduce, right? Or reduce row. I'm just going to say reduce row because it's a tongue twister. Mm-hmm. But this is also also gets the reduced row inverse, right? So then by doing that, right, then naturally, right? So then naturally, we get that the ABCD, and once we get those, but again, you're going to be using technology, so no worries. So I'm going to put a dot here to show, the 3 dots for that you're going to get A is 0.231818, B is equal to negative 4.48182, C is equal to 21.4136, and then D is equal to negative 2.16364. And then we just plug them in, right? That was your A, that was your B, that was your C, and then that was your D. So hopefully that makes sense. Now, how to get your errors, your R squared value for something like this. I really don't know how I would be able to do that with that technology. I'm not a statistician, I'm a mathematician. So applied math, and again, of course, that implies that we use technology when we see fit. Doesn't mean that applied mathematicians are weak in their stats. It's just kind of maybe, but not really. I guess we know the best way to do it. So a straight line can't reproduce that. So a straight line can't reproduce. Go ahead. So I'm going to explain something. Like you were saying earlier. Go ahead.
Like you were saying earlier that the folks who are not getting this, I don't think because it's a little way too advanced. I understand that, and I don't think you expect me to know all this in all one day. But what I am happy is at least we got the graph covered.
Yeah, in a way, I kind of do. I do expect you to do this because I'm going to do this method again when we start balancing equations. Okay, so I do want you to get used to this. Do you have your Ti84 on you?
Yes, I do.
Okay, so here we go. What's really important with that, what I want you to do is I want you to see. Okay, I want you to press second on your calculator.
Okay, I did. I press second.
Hold on, hold on. Hit 0. Press 0 for catalog.
Okay.
Scroll down to diagnostic on. You see it?
Diagnostic what?
Diagnostic on. You see it?
Spell that out for me.
Diagnosticon. Hold on.
I don't. Oh, diagnostic off. Is that what you said?
No, diagnostic on.
Okay, yes, I found it.
Okay,
I found it.
I think you're supposed to press enter on that. So
Okay.
hit enter again. And then
It says
hit,
done.
okay, and then hit second mode to quit. Okay,
Okay.
now, next procedure. Number 1, I want you to press stat. And then I want you to hit edit.
Okay.
Hold on a minute, I
I
gotta.
hit it. It's showing 3 columns.
And then I want you to, and under the first column, I want you to put, hold on a minute, for the, so what I'll have you do, it doesn't let you read title L1 that's programmed in, that's okay. We know it's time, right? I'll put time here for viewer and V here for the volume. Now, we know from our list we have 1, 2, 3, 4, 5, 6, 7, 8. So you'll start putting those in, right? You don't have to change L1.
All right.
And then you'll put 15. I forgot, but just make sure you're putting the data 21, 28, 24, 16.
It's 4 numbers, right?
No, we're going to do all of them. "21, 28, 24." Okay. Put your 24. My method gives you something, but this will give you exactness, right? It'll give you a better, best fit. The computer will, I think. While my method will give you something, it's qualitative. You can get numbers, but there is an associated error with that. So my method works. It just may not be as accurate. It may be pretty close, but I would assume that the computer would be more accurate. We'll see. So do 5. Notice how I say computer, right?
Uh-huh.
I bet the viewer thinks that we're using technology. We are, but this is even using technology. There are better technologies. So yeah, if teachers need to kind of get out of the hole by hand. You got to know how by hand, but you got to know. If I didn't know the math, I wouldn't know how to use all these different technologies. 6, 8. That's what I'm trying to say here. 7 and 2. I don't know if I need to say that. But okay. 8 and 1, 9 and 2.
So for L1, you put 1, 2, 3, 4, 5, 6, 7, and
Yeah,
10,
if you
11, 12, right?
yeah, that's exactly how I have it. That's right. I'm writing it like you need to write it. Yeah, that's why I'm showing you. 10, 3, 11, 5, 12, 10.
15, 15, 24. Does that say 21? 21.
Well, you know them. You've got them,
15,
man.
21.
No, get them. Make sure it's right. 21, 28. Like you've got it on the other slides, 24, 16. Kind of hard for me to write in here. 8, 2, 1, 2. Just make sure it's the. You need to make sure yourself. You've got the Ti84, and you've got the data. You need to make sure you're putting it in. Do you understand what the first list is? You got to make sure your coordinates line up, or it's going to be wrong, right? You understand that? Just make sure if you can't read my writing here that you are doing the right coordinates. Okay.
Equals ax cubed plus bx squared plus cx plus d.
Okay. Now.
And it says a equals 0.166
Okay. Okay. Slow down. Slow down.
0.076664.
Slow down. Slow
B
down.
equals
Now
b
that slow down. A is what?
0.166
0.166
40
40
7
7. Yep.
66
6x. Got it.
6
Three sixes.
4.
Wow, that's a lot. That was just A. Dang.
Yes.
That's why I said slow down. I was like, what's going on here? That is a lot. That's good. That means it's pretty accurate.
Okay.
It's just a lot. So what does B tell you?
Okay. Negative 3.0 523 920 52.
5.2.
Yes.
Okay. What does C tell you?
13.1 821
821.
32 68. By the way, it's not 17.1, it's 13.1.
Thank you. 3268. 1821328. Okay.
Yes.
And what does D tell you? You can go a
Yes.
little fast, see if I can catch it now.
6.535 3535
Again, tell me again.
3535
That's it.
35.
3.5 again.
That, yeah. And for the r squared value equals 0.8973 268 708.
So that means it's sitting at around 89, roughly speaking, 0.73% accuracy. That's good because that's, remember, right? We want to be close to 1%, 1, right? 1 is perfection, right?
Right.
0.8973 is a strong correlation.
Right.
So now that we have that, I want us to turn our attention again. We're going to turn our attention to what AI did. So notice that my method did give us it gave us the same R square, almost within 3 decimal places, right? It gave us this, within 3 at least, it gave us the same R squared value, didn't it?
Right.
So, but AI does that. I don't know how he would do that part of it. I did the rest of it, but I don't notice how it's a little different, right? So their R squared value with more decimal
Right.
places is a tad different, right? But pretty close. These functions are going to be pretty close to one another. So I've given you 2 ways to do it. The only thing we have to do now is how to get an R squared value from that polynomial. But since we know how to do it on the Ti84, we don't have to do that. This is as much as that they would expect. Now, if you wanted to do it without it by hand and just get something close, then you could do that, like using this method. And I like to provide that because it's more sciencey. But let's now go back. Now, what I want you to do is I want you to write that function down. So we're going to write it all down, right? what we're going to do, I'm going to show the user. Now notice how it's y of x, right? You only have L1, L2, blah, blah, and you only have y and x with these, okay? Equals
Right.
blah, right? Whatever your function is. But the reality is that your function now, this is why it's important that we don't get used to just letters, right? We know it doesn't matter what the letters are. So we need to put 0.166407666. I don't know if you need to do the whole thing, but I would. T cubed, right? Minus 3.052. Um, I would write this down. You don't have to write the whole thing, but I'm going to do it anyway.
What I would do is I'm gonna take a screenshot of it.
Right. And now we're going to do, what's the next one? Make sure my signs are, the right plus or minus. Make sure they're the right signs. 1821, because you got the data. T plus 6.53.
Anakin, Chancellor Palpatine is evil! From my point of view, the Jedi are evil